All right, Algebra 2, today we're going to look at doing these complicated graphs, these complex rational functions by hand, finding all these features without using the calculator. Okay, so what I've done here is the left side is the left column of the first page of your notes, and the right side is the first problem of all the examples. So I'm going to use that first problem, and we're going to do the notes along with the problem as we go. So in your packet, you're going to want to flip back and forth between the two pages. Okay, so first thing is x-intercepts. And of course, as you know, x-intercepts is where y equals 0. So that's what we want to find here, is we want to find the spot where y equals 0. Okay, so this is going to be the point something 0. So where is y going to equal 0 here? Where will this be 0? Okay, and hopefully you can see that if the top equals 0, we'll have 0 divided by whatever, doesn't matter. 0 divided by something will give us 0. So what we are going to do to find x-intercepts here is set the numerator equal to 0 and solve for x that way. Okay, so if we look at number 1 here, we need y to be 0 to get the x-intercept. How are we going to get that? Well, if we let this whole part up here equal 0, we'll have 0 divided by whatever, which will be 0. So we have 3x squared equals 0. Okay, hopefully some of you can see the answer right away, but if not, just follow your math process. Divide by 3, so x squared is 0 divided by 3 is 0. Square root, square root of 0 is 0, so x equals 0. So our x-intercept here becomes the point 0, 0. All right, then we have y-intercept, and the y-intercept is when x equals 0. Okay, so all we're going to do there is just let x equal 0. And we're going to find the point 0 something. Hopefully on number 1 here you see already that if you plug in 0 for x, you're going to get 0 for y because we already found that point once. But let's actually plug in and see that work. Okay, so here I'm going to go back to the original problem, and I'm going to plug in 0 for x, and 0 for x here, and we end up with 3 times 0 on the top, or 0 over negative 1, which is 0. So again, we get the point 0, 0, but we're not surprised by that. Okay, vertical asymptotes. Vertical asymptotes, if you remember from doing these in the graphing calculator, are these vertical dotted lines that the graph never touches. So these are x's that the graph never touches. Okay? So we're going to call these values for x that make the graph or make the function undefined. Essentially what we're doing here is x doesn't work. Okay, so what can we do to x here, or what kind of x's wouldn't work? Well, what doesn't work is when the bottom is 0. That doesn't work. That makes this function undefined when the bottom is 0. So what x's make the bottom 0? And that's what we're going to do here. We're going to make the denominator equal to 0. Because if it's equal to 0, whatever x's make the bottom 0, make this function undefined at that point. Okay, so going back over here to our example, what things, what functions, or what x values make this function undefined? Whatever's undefined is dividing by 0. So what x's would make that happen? X squared minus 1 equals 0. We can factor that as x minus 1, x plus 1 equals 0. So x is 1 and negative 1. You can see here, if we plug in 1, we get 1 squared minus 1, we get a 0 on the bottom. You can't divide by 0, so that x doesn't work for this function. And same with negative 1. So our two vertical asymptotes are the two x's that don't work. And that's x equals 1 and x equals negative 1. Okay, now for horizontal asymptotes. Horizontal asymptotes are a little bit more complicated, and they depend solely on the degree of the top of the fraction versus the degree of the bottom. So what we're going to do here is we're going to say that the top degree, if the top degree is less than the bottom degree, and what does degree mean? Degree means biggest exponent. So if the top degree is smaller than the bottom degree, then our horizontal asymptote is y equals 0. If the top degree is bigger than the bottom degree, then there isn't a horizontal asymptote. Then you're just going to say none, there isn't one. And if the top degree is equal to the bottom degree, then it's going to be the ratio of the leading coefficient on the top over the leading coefficient on the bottom. So what do I mean by that? I'm going to say that y is going to be the leading coefficient on top over the leading coefficient on bottom. Okay? We have three choices for horizontal asymptote. Horizontal asymptote is either y equals 0, none, or the leading coefficient on top divided by the leading coefficient on the bottom. It's one of those three things, and it's based on the degree. Okay, so if we look at our example here, we have the degree on top is 2. The degree on bottom is 2. So both of these are the same degree. So what we have is the third scenario here. The top degree equals the bottom degree. So what we have is the leading coefficient on top, which is 3, over the leading coefficient on bottom, which is that imaginary 1. So what we have here is y equals 3 over 1, or just 3. So this is y equals 3. Now the domain is always all reals except where x can't be. Okay? And where can't x be? X can't be where the vertical asymptote is. Okay, so what we're going to do here for domain is we're going to say that this is all reals except 1 and -1. This graph, if you look at it, will hit everything except 1 and -1. So down here we can write in that this will be all reals except the vertical asymptotes. Now unfortunately range isn't quite so easy. And kind of lied by telling you that this is all non-calculator, because the range can't be done without the calculator, because you need to see the picture of the graph. And since we're not necessarily going to make you draw these because they are super complicated, we are going to have you just graph at these. So we're going to look at the graph when we're talking about range. So when it comes to the quiz, we may give you the graph, okay, because the quiz will be non-calculator. You wouldn't have to draw it yourself. So let's put this into our graphing calculator and, whoa, see what the range looks like. Okay, so here in our calculator, okay, I think I cut myself off there for just a second, but here we are. What we're doing is putting this into the calculator so we can look at the range. So we're going to go to y equals, and we're going to clear whatever's there, and we're going to type the top in parentheses. So in the top in parentheses, we're going to type in 3x squared, and then we're going to end parentheses, divided by, and we're going to put the bottom in parentheses, x squared minus 1. And we're going to graph. You may have to zoom standard. And there we go. So a couple things that we know here. We know that this point right here is 0, 0. And we know that this vertical asymptote or this horizontal asymptote is at y equals 3. Okay, so if we look at the purple drawing on here, we know that this part of the graph, the top part of the graph, lies directly above 3. So we're going to say that top part is y is greater than 3. And the bottom part is here at 0 and below. So we're going to say that y is less than or equal to 0. Okay, so there's our range. Okay, so moving on to the other type. Okay, this would be the right column of your notes. They look a little bit different. They only have x's on the bottom in the denominator, and then there's this plus k. So how are we going to find x-intercepts? Well, to find x-intercepts, we're going to do what we've always done. And we are going to plug in 0 for y and solve. Nothing new, nothing special. Plug in 0 for y here, so we have 0 equals 5 over x, sorry. 5 over x minus 2. How do you solve for x? Well, first we're going to add 2 to both sides. So we get 2 equals 5 over x. And now if you want, put the 2 over 1 and cross multiply, or multiply both sides by x, whatever it is that you want to do. We end up with 2x equals 5, and so x equals 5 over 2. So our x-intercept is 5 over 2, 0. Okay. Okay, our y-intercept, ignore that. Our y-intercept now is, again, the same thing that we've been doing. Our y-intercept means we plug in 0 for x and solve for y. So we're going to plug in 0 for x and solve. So essentially we're letting this bottom part equal to 0. So in this case we're going to set this to equal 0. We have 5 divided by 0. That's undefined, and therefore there aren't any y-intercepts, okay, because that x equals 0 is undefined, so it can't cross the y-axis anywhere. Okay, our vertical asymptotes is going to be similar to what we had before. The vertical asymptote is going to be where x can't be. Okay, so we are going to find the x's that make the function undefined. So find the x's that make f of x undefined. What's going to be undefined? Undefined is if we divide by 0. So this equals 0 would make an x that doesn't work. So we are going to let that denominator equal 0. Let the denominator equal 0. So on number 2, if we let the bottom equal 0, well, that's just going to be x equals 0. Okay? So if we set this equal to 0, we just have x equals 0. So our vertical asymptote is x equals 0, which makes sense and goes along with our y-intercept that we found that x can't be 0. So that's an asymptote. That's where the graph won't touch. Okay, now the horizontal asymptotes here are going to be nice and simple. That's just going to be y equals k. Okay, so way easier than the other type. That's going to be y equals k. So on number 2, we're just looking at y equals -2. Okay, domain is going to be very similar to the other problem. Well, in fact, it's going to be exactly the same as the other problem. Domain is going to be all reals except the vertical asymptotes. Okay, so that's going to be all reals except vertical asymptotes. So this is all reals except 0. And for these, the range is also going to be very simple. We don't actually have to look at the graph of these because they're always the same. Here we're going to have all reals except the horizontal asymptote. So this will be all reals except -2. Okay, so that should be 2 examples for you and some notes. I am very quickly here running out of time. Sorry for the super long video, but hopefully this was helpful and that you should be able to do the couple problems left in the notes. So make sure you attempt those and we will go over them in class tomorrow. Have a great day.